What is data science analytics of a web from a developer point of view? Web analytics. Web analytics deals with the collection and analysis of data on the user visits on websites and cloud applications. Analysts of the data can give insights about the user engagement and tracking the performance of online advertising campaigns. For collecting data on user visits, two approaches are used. In the first approach, users visits are logged on the web server that which collects data such as the date and time of the visit, resource request, users, IP address, HTTP status code, for instance. The second approach, called page tagging, uses a JavaScript which is embedded in the web page. Whenever a user visits a web page, the JavaScript collector uses user data sends it to a third-party data collection service. A cookie is assigned to the user, which identifies the user during the visit and subsequent visit. Performance monitoring. Multi-tier web and cloud applications such as e-commerce, business-to-business, healthcare, banking and financial, retail, and social network applications can experience rapid changes in their workloads. To ensure market readiness, such as applications, adequate resources need to be provisioned so that the applications can meet the demand of specific workload levels at the same time. Ensure that the service level agreements are met. Financial credit risk modeling and fraud detection. Credit risk modeling. Banking and financial institutions uses credit risk modeling to score credit applications to predict if a borrower will default or not in the future. Credit risk models are created from the customer data that includes credit scores obtained from credit bureaus, credit history, account balance data, account transaction data, and spending patterns of the customers. Credit models generate numerical scores that summarize the credit worthiness of customers. Since the volume of the customer data obtained from multiple sources can be massive, big data systems can be used for building credit models. Big data systems can help in computing credit risk scores of a large number of customers on a regular basis. Fraud detection. Banking and financial institutions leverage big data systems for detecting frauds such as credit card frauds, money laundering, and insurance claim frauds. Real-time big data analytics frameworks can help in analyzing data from disparate sources and label transactions in real time. Machine learning models can be built for detecting anomalies in transactions and detecting fraudulent activities. Batch analytics frameworks can be used for analytical for analyzing historical data on customer transactions to search for patterns that indicate fraud. Vector regressor. This is the vector regressor. Code. Linear classifiers. Which hyperlink? Lots of possible solutions for ABC. Some methods for finding a separate hyperplane but not optimal. Example, perceptron. Support vector machine finds an optimal solution. This line represents the data decision boundary AX plus BY minus C equals 6. Supports vector machine, finds an optimal solution. Maximizes the distance between the hyperlink and the difficult points close to directory. One intuition. If there are no points near the decision surface, then there are no very certain classification decisions. Another intuition. If you have to place a fat separator between classes, you have less choice so that the capacity of the model has been decreased. Support vector machines. SVMs maximize the margin around the separating hyperway, aka large margin classifiers. The decision function is fully specified by a subset of training samples to support vectors. Solving SVMs is a quadratic programming problem, seen by many as the most successful current text classification method. Maximum margin formalization. W decision hyperplane normal vector. Xi data point I. Yi class of data point I. Not 1 over 0 classifier is f of xi equals sine wtxi plus b. Functional margin of x is yi wtxi plus b. But note that we can increase the margin simply by scaling wb. Functional margin of dataset is twice the minimal functional margin for any point. Factors of 2 comes from measuring the whole width of the margin. Geometric margin. Distance from example is the separator is example closest to the hyperplanar support vector. Margin P is the separator is the width of the separation between vectors of classes deriving a function finding our dotted line xx is perpendicular to decision boundary so parallel to w. Unit vector is w divided by u, so line rw over rx minus yr satisfies the x the derivative of x plus b. Recall that w square root of p, so solving for r will geometric margin format. R equals y w t x plus b w w. Geometric margin graph. On your SVM mathematically, the linear separatable case, assume that all data is at least distance 1 from the hyperplane, then the following two constraints for a following training set xi, yi for support vectors, the inequality becomes an equality. Then since each example's distance for the hyperplane is linear SVM mathematically. Linear support vector machine, hyperlane, extra scale constraint. This implies oh. linear's SVM mathematically, then we can formulate the quadratic optimization program. Find W and B such that P equals 2 over. A better formulation, min W equals 1 over W. Find W and B such that data conditioning refers to the process of cleaning data, normalizing datasets, and performing transformations of the data. A critical step within data analysis lifecycle, data conditioning may involve many complex steps to join or merge datasets or otherwise get datasets involved datasets into data conditioning is often viewed as pre-processing step for data because it involves many operations because on data before developing models to process or analyze the data. This implies that the data conditioning step is performed only by IT data owners, a DBA, or a data engineer. Functional margin represents the correctness and confidence of the prediction if the magnitude of the vector is orthogonal and to the hyperplane. B correctness of by correctness the functional margin should By correctness, the frictional margin should always be positive, since if wxb is negative, then y is negative 1. If wx is positive, y is 1. If the functional margin is negative, then sample should be divided into the wrong group. Find W and V such that O of 1 equals Wt is minimized for all x1, y1, y1 is. This now optimizes a quadratic function subject to linear constraints. The solution involves constructing a dual programmer language multiplier AI associated with the thing is that the optimization problem solution W equals each non-zero AI indicates that the corresponding xi is a support vector. Then the classifying function will have the form. Notice that it relies on a inner product between the test point x and the support vectors xi. We will return to this process. It also keeps in mind that solving the optimization problem is about computing the inner products between all pairs of training points. Soft margin classification. If the training data is not linearly separable, slack variables can be added to allow misclassification of the difficult or noisy examples. Allow some errors. Let some points be moved to where they belong to at all costs. Still trying to minimize training set errors into place hyperplane far from each class. Larger margin. Soft margin classification mathematical. The old formulation find WB such that O of 1 WT is minimized for all. A new formulation incorporates slack variables find W and B. O of T is minimized and for all. Parameter C can be viewed as a way to control overfitting, a regularization term. Soft margin classification. So dual problem for soft margin classification. Find A of 1 such that Q of A is maximized. 1 is equals 0 is less than or equal to AI. A of I. C for all. Neither slack variables I nor their Lagrange multipliers appear in the dual program. Again, with xi with non-zero AI will be support vectors. Solution to the dual program is that W is not needed explicitly for classification. Classifications of SVM. Given a point X, we can score its projection into the hyperpoint model. Example, compute score, decide class based whether on less than or greater than 0, can set confidence threshold T score or greater than T, yes, scores less than or T, no, else don't know. Linear SVM summaries. A classifier is separated between the most important training points are the support that define the hyperpoint quadratic optimization algorithms can identify which training points X and I are both in dual formation of the program. Training points appear only in that maximize when doing that.